All right, I gotta go quickly or this video is gonna take forever to do, so be paying attention. So what is a function? For every input, there's exactly one output. So input is X and output is Y. So for every input, there's exactly one output. So if you were looking at it in a map, so let's go 3, 5, 6, 2, and let's do 1, 7, 8, okay? So this is acceptable. Why? Because 3 only has one answer, 5 only has one answer, 6 only has one answer, and 2 only has one answer. But look, it has the same answer. That's fine. Okay, you got to think of an equation. If I'm making an equation, okay, and I'm putting a number in it, okay, the output should be one number. So if I put 3 in an equation, or whatever equation that this is making, the answer is 1. Okay? If I put 3 in, I'm not allowed to have a different answer. If I put 3 in the equation and the answer is 1, I should get 1 every single time I put 3 in the equation. It shouldn't change. So for every input, there's exactly one output. So this is totally a function. What's not considered a function is if I did something like this. The 3 has 2 answers. Okay? That's not allowed. You're not allowed to have 3 equal 1 sometimes and 3 equal 8 sometimes. Okay? It's not a function. Same thing for the graph. Okay? This, okay, even though it's not linear, it's still totally a function. All right? It's totally a function. But how would this look if it wasn't a function? Okay, how would it look if it wasn't a function? It would go like something like this. Okay, why? Because if I look somewhere, like here, let's pretend here, if I look here, how many different answers does this X have? It has this answer and it has this answer. Wait a minute, it has even another answer. Okay, so seeing as though X has multiple answers, this is not a function. Okay, if you erase this, then yeah, it's only a function. No matter where I choose, I only have one answer. Okay? So that's totally acceptable. All right? If I give you something like this, so that was a continuous line. Okay? I also can do something like this. Okay? Not connected, like this. Okay? So if it's not connected, you still can tell me if it is a function or not. Okay? Here we go, here we go, here we go, here we go. Ah, I see a mistake. This X right here has 2 answers. That's not allowed. Okay? So this is not a function. But if I erase this, totally a function. No issue at all. Okay? So first part of this is, can you see if something is a function or not a function from the coordinates, meaning every single X can only have one answer. Okay? Now, can the answers repeat? Yeah. Answers can repeat all they want. But the X's can only have one answer. Okay? All right, so let's keep on going here. This is function notation. Okay, it's a little switch. It used to say Y equals this stuff and Y equals this stuff, but now it says F of X equals this and G of X equals this, or H of X or H of G or whatever it is. Okay, so function F. So this is the formula for F right here. Okay, with X in it. This says same formula as F, but with a -1 in it. So I'm going to replace, so I'm writing, I'm writing it exactly the way that one is. So -2, there's a -3, but I'm replacing X with -1, okay? I'm replacing X with -1. So now you multiply these two, okay? These two are going to multiply. I'm just going to underline what I'm changing. So I'm changing this. So this is going to multiply and make 2 minus 3, and then 2 minus 3, that's going to make -1. So there's my final answer. So what's the answer for F of -1? -1. Okay? What's the answer of G of -3? Well, the original said something squared plus 5, and then that something, that x. But I'm replacing x. You see how it used to have x here? Now it has -3. So I'm replacing that. All right? So I'm replacing that with -3. So -3 goes here, and there's going to be a -3 right here. So let me put a parenthesis around both. Okay, so -3 is being squared. So -3 times -3 is going to be 9. So that's going to be 9. So change this. I'm also going to change this. 5 times -3, or a positive 5 times -3, is going to make -15. And then I'm going to change this. 9 minus 15, that's going to be -6. So what's the answer of G? G of -3? The answer is -6. Okay? That's as small as I can make it. Here, we're going to do the same thing. See if I have any space to kind of run over here. Okay. So let's do, we're doing F. So let's do that in purple. And the stuff we put in, we'll put in black. Okay, so -2 is still here. And then -3 is over here. But we're replacing x with 4y. So I'm putting 4y. Okay? So normally if they change the letter, you just leave it like that. But here I can do something. So I have to, if I can do something, I have to do it. Here I can do something, I can do it. I'm done at the end, so I can't do anything else. Here I have to keep on going. So here I have to do the distributive property, or multiply here. I don't have to do the distributive property. So -8y minus 3. Can I join these together? I can't. So that's my end result. That's what f of 4y equals. Okay? So that is function notation. Pretty simple. All right, let's go over here. Now we're going to go to percent of change. Slightly out of order of the way I've taught it, because I need all of those previous graphs, and they're all at the top. So we'll deal with this right now. So this is percent of change, okay? Percent of change. So how much did it change? So here, okay, original was $78, and the new price is $125. So this is an increase. So we already know this is an increase. So I'm not too worried with the order of the top. So you just have to subtract the top. So I'm just going to always do big minus small. And that's going to be divided by the original, which is 78. Okay? And that has to equal, so 78 is 100%. Okay? Now, once I figure out what this is, what's 125 minus 78? That's 32, and then 25, so that's 57. So this is going to make 57. So I'm going to erase this. So it changed $57 from the original. Changed 57 from the original. So what if this is 100%? How much percent is this change? Percent of change. So this is the percent of the change. So this is my mystery. I don't know what this is. Well, I have an equal sign next to two fractions. I know what to do. Cross multiply. So this is going to make 5,700 equals 78x. Then you divide by 78 to leave the x by itself. Divide by 78. And your answer is going to be your percent of increase, because we know that it increased. So let's figure that out. Let's see if I have any space to do a division problem. I'll do it over here and then erase it. So 5,700 divided by 78. Okay. So 78 does not go into 5. It doesn't go into 57, but it does go into 570. So 5 would be 390. 4 would be 4. So I'm going to say 5. No, 5 would be 390. So 6, 7. Let's go with 7. 7 times 8 is 56. 7 times 7 is 49 plus 5. That's 54. I think we chose correctly. This is going to subtract, and we're going to get, let's see here, that becomes a 6, that becomes a 10. So we're going to have 4, 2, that's 0, drop down to 0. So now I have 240. So let me see. It's about, it's less than half. So it's less than, so it's, I'm gonna say 3. 3 would be correct, yes. So 3 times 8 is 24. Okay. 3 times 7 is 21 plus 2, that's 23. I'm gonna subtract and I'm gonna get, let's borrow here, that's a 3, that's a 1. We're gonna have 6 and then 0, right? So here's our decimal point because it's the end, all right? Now, how many 78s go into 60? 0. So that helps me because I was gonna round to the whole numbers, okay? So 73.0 rounded to the whole number is gonna be 73%. So 73% increase is my final answer. That's how much the price went up. Okay, I should have bought it when it was $78. What's wrong with me? Okay, so 73% increase from its original amount. Okay, so now let's do this one. So this one, the original was 41 and it went down to 24. That's what you were hoping about this one, but that didn't happen. So this is a decrease from the original. So we know the answer is going to be decrease. Okay, so now I'm going to do 41 minus 24, and that's going to be under the original, which is 41. Because I want to know what the original changed. 100% is 41. That's the original. I want to know how much it changed. So after you do 41 minus 24, that's going to give us, that can be 20, 3 less than 20, so 17. So 17, 41, and that's 100, and this is our mystery percent. Cross multiply. 1700 equals 41x. Divide by 41. Divide by 41. That's a 40, by the way. I said 41 when I wrote it, just in case. So now we have 1700 divided by 41. Here's the decimal point. I'm just going to want one number after because I'm going to round to the whole number. So 41 go into 1? Nope. 41 go into 17? Nope. How many times does 41 go into 170? So that's going to be 4, right? 4 times 1, that's going to be 4. 4 times 4 is 16. That's going to leave me with 6. Drop down to 0. How many 41s go into 60? Just 1. That's going to be 41. I don't know why that took me so long. And that's going to be 19. Okay, so I am going to have to add a 0. How many 41s go into 19? Okay, 4 would have been 164. I already know that. Another 1 would have been too much. So this is going to stay at 4. Okay, I don't have to do the rest of the math. I just want to know what number that was. You could double check. 164. Yeah, that's the right number. Okay, if you would have done another 41, it would have gone to 200s. It would have gone too far. So 41.4. So this number makes me round down, so 41%. So this was a 41% decrease. You do have to say increase or decrease, but it's pretty obvious right from the get-go. All right, let's go up. This one, total price. Okay, so now they told you the discount and they told you the increase. So taxes makes things go up, discounts make things go down. So this one, they told you the total price. So you know it's $22.50, right? And this is 100%. Okay, but it went up 7.5%. So we know that there is a percent of change of 7.5%. But what is 7.5%? I'll just add it to this one and I'll know. So let's find out what it is. This is the change. Okay? So we cross multiply, and now we have 100x equals whatever 7.5 times 2250 is. Multiplying, much easier for everybody. So 22.5 times 7.5, that's going to be 25. That's going to be 12. That's going to be 11. That's going to be 35. That's going to be 14 plus 3, 17. And that's going to be 14 plus 1, 15. 5, 7, 8, 6, 1, with two numbers behind the decimal point, 168.75. So 168.75. Divide by 100, divide by 100. Luckily, this is very easy. You just move the decimal point twice. So my answer is going to be x equals 1.6875. Remember that this is money, so it's going to round. So x equals 1.69. So I know that the taxes increased this price by $1.69. Okay, so that was the increase. So I just had to add $1.69 to this. So our answer would be 911, and then 2, 3, 4, and 2. So our total price at the end is $24.19. Okay, if you were using a calculator, a lot of this stuff would take much less time, but I like to do everything by hand, so there you go. All right, so this one, a discount, means the price is going down. Okay, the price is going down. So let's do that one. So if the price is going down, I have to figure out how much to take away from the total price of this. So we still have to figure out what the change was. So 95 is all of it. That's 100%. Okay, I know that the price changed by 15%, but what was it? I know it went down by 15%, but what is it? I have to find out what 15% is, and then I'll take it away. So again, this is our mystery round, the change. Okay, so cross multiply. You figure out that it's 100x equals 95 times 15. 95 times 15 is 25. That's going to be 45, 47, 0, 5, 9. It's going to be 5, 2, 1, 14. So it's 1,425. Divide by 100. Divide by 100. That just moves the decimal point twice. So x equals 14.25. If you're wondering what I mean by moving the decimal point twice, it means I'm moving the decimal point twice. So $14.25 was the discount. So I have to subtract that from this. Okay, so I have to subtract that. So if you subtract it, you're going to get 9500 minus 1425. So that's my discount. So it goes down by a considerable amount. That's 10, that becomes 9, that becomes 10. So now we have a 5, a 7, a 0, and a 8. So now it costs $80.75 that guitar. You know, you should have gotten higher the more I did this. So you're going like, so, but whatever, it doesn't matter. That is total price. Not that bad. Okay, now let's talk about graphing, labeling or describing a graph. Okay, the first thing we're going to talk about is x and y intercepts. X intercept, so the graph is the black lines. The line is the purple. You have to tell me, when does this purple line intersect with x? So if I was telling you the x-intercept, I would say the x-intercept is -3, 0 and 4, 0. So right here and right here is when this line intercepts with the x line. Okay, when's the y-intercept? The y-intercept is when does this purple line intersect with this line, which is right there. So the answer for this one is 0, 2. Okay? So that's how you find the y-intercept. Is this linear or non-linear? That's the other question. Okay? Linear means a straight line. What do I mean by straight line? I mean straight line, looks like a ruler. You can use it to make a straight line on the floor. Straight line. Or non-linear, which means non-straight. Okay? So this is non-linear. All right? Does this have symmetry? Symmetry, meaning is there anywhere that I can fold it so then the graph lands on itself? No, this has no symmetry. Okay? All right, next one. For a second, this looks like it has a line of symmetry, but it does not. There's nowhere you can, if you fold it, this is gonna not land on that. So it doesn't have symmetry. This one is indicating when something is positive and when something is negative. Okay? So all of this is positive. Everything in green is positive. Then all of a sudden, anything below this line is negative. Then back to positive, back to negative. So anything below, so this is your marker for the line here. Okay? Let's use a color I didn't use, blue. So anything, ooh, not thick enough. Okay. Anything above this line is positive, anything below this line is negative. So how would you describe this? Okay, when is it positive? When is it positive? Okay, when is it positive? When you describe a location, you use X to describe a location. So location starts here, so -4, right? Anything on the left, -4. So when X is less than -4, it's positive. And from here to here, right? So from 0 to 5 also. And between X equals 0 and X equals 5. Okay? X equals 0 and X equals 5. All right, pretty good. And when is it negative? Let's describe when it's negative. Okay, so negative. It's negative from -4 to 0, so between X equals -4 and X equals 0. Where else is it negative? Well, anything to the right of 5 is also negative. Okay, so, and when X is greater than 5, it also is negative. Okay, so now we're going to talk about increasing and decreasing. Okay, when is this increasing and when is this decreasing? So if you pretend this is a roller coaster, it's very simple to realize when something is increasing and something is decreasing. So if you look at it from left to right, when it's going down, it's decreasing, and when it's going up, it's increasing, and then going down, it's decreasing. Okay, so if you have, you have this guy over here enjoying the ride here. Woo! Okay. He lost one eye in a roller coaster accident, but he still loves roller coaster. So he's on the roller coaster. This is him going down, right? And when he gets here, all of a sudden it's like going up, 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 and then all of a sudden back down, having a blast. So anytime that I was going down is it going decreasing, and then anything going up was increasing. So it's not that bad. Okay, so all of this is increasing up to here, which we call -3, and it's increasing up to here, which we'll put at 3 right now. I know it's not there, but let's put that there. Let's pretend it's at 3. So when is it decreasing? All of this is decreasing. So when X is, so decreasing, all right, DEC. So when is it decreasing? When X is less than -3, and when X is greater than 3. That's when it's decreasing. When is it increasing? Okay, well, when is it increasing? It's increasing from X equals -3 to, or between X equals -3 to X equals 3. And that's when it's increasing. Okay? Now, the other part of this is, what is the relative extrema or relative minima? Meaning, is there a place where it changes from increasing to decreasing, decreasing to increasing, or increasing to decreasing? That does happen twice in this graph. Happens right here and right here. Now, I know that this is not the minimum because this goes down forever. I know that this is not the maximum because it goes up forever over here. But in this area, this is the largest thing. So every time this changes, anytime there's like a hill, anytime there's like a dip like this, that's a relative, meaning just, right now, relative extremum. Okay? So this is the relative maximum, relative max is at x equals 3. And the relative minimum is at x equals -3. All right? And then the last thing is end behavior, is another way you can describe information. So what's going on with this when you go to the left? What's the end behavior on the left? Well, what left means that x is going down. So x is decreasing. Okay, so the x is decreasing. All right, but what's happening to the y? What happens to the y every time I move to the left? It's going up. So y is increasing on the left. So the left end behavior is this. What about the right? What if I keep on going to the right? What would be the end behavior here? Well, now x is going up when we go to the right. So this is going to always be increasing. Okay? But the y is going, every time I move to the right, the y seems lower. So the y is decreasing. Okay? So that's what's going on there. All right? This. All right? So that's what's going on there. And that's it. See you guys.